Greetings, fellow travelers through time. Settle in, find your comfortable space, and let the whispers of antiquity carry you away. Tonight, we journey to a land where humanity's story truly blossomed the vast and ancient expanse of southern Africa. Forget what you thought you knew about the dawn of our species, because here, in the oldest landscapes, our ancestors were not just surviving, but thriving, innovating, and dreaming in ways that will utterly transform your understanding of human beginnings. Prepare to uncover secrets etched in stone and bone, spanning a million years of incredible ingenuity and profound change. If you find yourself enjoying this expedition, please consider leaving a like, a comment, or sharing it with another curious mind. Now, let us begin our deep dive into the primal heart of our shared past. Welcome back, my friends, to Vibing History. Settle in, get comfortable, and let's journey back to a time so ancient it reshapes everything we thought we knew about human ingenuity and survival. Tonight, we're not just talking about history. We're diving into the very cradle of our species, a place where the embers of human intelligence first flickered into a roaring flame. We're heading to Southern Africa, a landscape that holds secrets stretching back millions of years, a profound and captivating narrative that truly deserves our deep immersion. Imagine a world a million years before now. The air is different, the land is raw, untamed. It's a place where survival is not just a challenge, but a constant, brutal negotiation with nature itself. Yet, it is here, in the depths of Wonderwork Cave in South Africa, that we find the earliest undeniable evidence of something truly revolutionary. Hominins controlling fire. Think about that for a moment. Not just stumbling upon a wildfire, but actively harnessing its power. This wasn't just warmth. It was protection from predators, a way to cook food, and a beacon in the darkness. It was a technological leap, a monumental shift in our ancestors' ability to shape their environment, laying a foundation for all the wonders that would follow. Now, fast forward a bit. Not a small bit, mind you, but another vast expanse of time. We're talking about a period stretching back as far as 260,000 years ago, and certainly before 150,000 years ago. This is when the ancestors of the Khoisan people, those who would become the ancient heart of southern Africa, began their expansion into this fertile, diverse land. Picture them, moving, adapting, their footsteps marking the land with an indelible legacy. It's theorized that these early Khoisan ancestors, due to their early expansion and a relative isolation, might have formed the largest population among all anatomically modern humans, a demographic powerhouse, until the monumental out-of-Africa migration around 70,000 years ago. It paints a picture of a vibrant, thriving human presence, deeply rooted in this southern land long before others ventured out to populate the rest of the world. And here's where it gets truly fascinating. Around 200,000 years ago, the genetic threads of humanity began to diverge. Africans, including those ancestral Khoisan in southern Africa, carrying what we now call haplogroup L0 separated from other African groups further north, who carried haplogroup L16. This genetic marker, L0, is like an ancient fingerprint, tracing back to the earliest branches of our family tree, placing southern Africa squarely at the heart of our very origins. Between 130,000 and 75,000 years ago, something extraordinary began to blossom in southern Africa. Behavioral modernity. This wasn't just about surviving, it was about thriving with a new level of sophistication. This era saw the establishment of long-term interactions between southern and eastern Africa, hinting at burgeoning networks of exchange and shared knowledge. It suggests a complexity of societal structures, a far cry from the simplistic narratives sometimes painted of early humans. Imagine their lives. By at least 170,000 years ago, amidst the Middle Stone Age at a place called Border Cave in South Africa these early southern Africans weren't just eating what they could forage. They were cooking and eating the rhizomes of Hypoxis angustifolia, a plant that likely provided essential carbohydrates, a vital energy source for their increasingly active, mobile lives. This wasn't random. This was intelligent foraging, dietary strategy, and a deeper understanding of their environment. At the renowned Claces River Caves a treasure trove of ancient human history, researchers unearthed finger bones dating back between 100,000 and 90,000 years ago. These aren't just any bones. They offer a glimpse into the physical characteristics of these ancient individuals. They are from an adult, yet appear smaller than modern human populations, and interestingly, are not comparable to Neanderthal phalanges. What's even more intriguing is their similarity to phalanges found in Die Kelder's cave, which some authors suggest are more akin to the Holocene Khoisan populations. This provides yet another tangible link, a skeletal echo, connecting these deep ancestors to the Khoisan who would later spread across the land. And the narrative continues to unfold. By 92,000 years ago, further north, in what is now Malawi foragers were already employing fire not just for cooking, but to actively influence and alter their surrounding environment This speaks to an early understanding of ecological management, a deliberate engagement with the landscape, perhaps for clearing land, encouraging new growth, or aiding in hunting strategies. It's a testament to their growing intelligence and their ability to manipulate the world around them. Then we come to Blombo's Cave a site that has utterly revolutionized our understanding of early human cognition. Imagine, 73,000 years ago, Southern Africans were inscribing small rock fragments with drawn abstractions These weren't utilitarian marks. These were symbolic expressions, a prime indicator of modern cognition, as researchers have called them. Think of the leap in thought required for this, the ability to create and understand abstract representations, to imbue an object with meaning beyond its physical form. This discovery, along with evidence of scraped and ground ochre likely used as pigment for body painting at another site, pp 13b, around 70,000 000 years ago powerfully contradicts the old classical hypothesis that modern behavior only emerged 40,000 years ago through some grand cultural leap. The evidence from southern Africa paints a much more gradual, sophisticated emergence of these traits, pushing back the timeline significantly. It's thought that the harsh climate and reduced food resources of the time may have driven people to the shores of Pinnacle Point where a new world of marine resources awaited them. Shellfish, whale, seal a bounty of the ocean providing sustenance and allowing these populations to thrive and innovate. This adaptation to coastal living, the exploitation of diverse food sources, is another marker of their remarkable flexibility and intelligence. And the innovations didn't stop there. Between 65,000 and 37,000 years ago, amidst the transition from the Middle to Late Stone Age Southern Africans developed the bow and arrow This wasn't just a new weapon, it was a fundamental shift in hunting technology, allowing for greater range, accuracy, and efficiency. It changed hunting dynamics, provided more reliable food sources, and likely influenced social structures. Then there's the Lebombo bone found in the Swaziland and South African mountain region, which might just be the oldest known mathematical artifact in the world. Dating back to 35,000 BCE, this baboon fibula bears 29 distinct, deliberately cut notches. While its precise purpose remains a subject of debate, perhaps a lunar calendar, a counting tool, or a record-keeping device, its existence speaks volumes about the advanced cognitive abilities of these ancient peoples, their capacity for observation, abstraction, and the recording of information. It's a silent, notched testament to early mathematical thought. As we move into the later Stone Age around 75,000 years ago, the **san populations those ancestral Khoisan, were widespread across much of southern and eastern Africa. Their deep roots and expansive presence highlight their enduring connection to these lands. Then, around 20,000 years ago, these populations, carrying haplogroup L0d, saw further expansion, a movement that some scholars connect with the spread of click consonants into East African languages like Hadza. This suggests a complex interplay of human migration, cultural exchange, and linguistic development, all unfolding across this vast continent. The later Stone Age Sangoan industry characterized by its distinctive tool-making, occupied parts of southern Africa where annual rainfall was less than a meter. This demonstrates an adaptation to drier, perhaps more challenging environments, showcasing their ability to thrive in diverse ecological niches. And the story of innovation continues at Sibudu Cave a site that has delivered a breathtaking array of early human technology. Imagine a bone point a probable arrowhead, pushing back the origin of bow and bone arrow technology to an astonishing 61,000 years ago, at least 20,000 years earlier than previously thought. This is a game changer for understanding the development of projectile weaponry.
Asterisk the earliest known bone needle also dated to 61,000 years ago, showing wear patterns consistent with puncturing animal hides. This points to sophisticated clothing, shelter construction, and advanced fiber technology, hinting at a remarkable level of comfort and adaptability in cold or harsh environments. Asterisk the earliest example of a compound glue a mixture of plant gum and red ochre, used for hafting stone points onto wood handles to create spears, dating back no later than 71,000 years ago. This is not just glue, it's a complex multi-component adhesive, demonstrating an understanding of chemistry and material science far beyond what was once assumed for this period. Shell beads though slightly more recent than those at Blombo's cave, at 71,000 years ago. These adornments speak to symbolic thought, self-expression, and perhaps even social signaling. Evidence of the earliest use of bedding approximately 77,000 years ago, with Cape laurel leaves placed on top likely for their insecticidal properties. This reveals an incredible level of foresight and a desire for comfort and hygiene, truly making a home out of a cave. And astonishingly, the earliest use of milk, casein, as a paint binder in a mill-coker mixture, 49,000 years ago. This is a testament to their experimentation with materials, their artistic inclination, and their deep knowledge of their environment. At Sibudu Cave, they also found dried fruits, carbonized and uncarbonized seeds, and nuts from the Middle Stone Age, dating from earlier than 60,000 BP to approximately 37,000 BP. This bounty of botanical remains paints a picture of a diverse and sophisticated diet, a deep knowledge of edible plants, and perhaps even rudimentary forms of food preservation. Like the earlier still bay industry, the creators of the Khoisan's port artifacts were also deeply engaged in symbolic behavior. They left behind engraved ochre, ostrich eggshells, and shell beads. The site of Khoisan's port dates to at least 50,000 years ago. The particularly abundant and diverse use of ochre as a pigment for objects or skin has been interpreted as reflecting an increasingly complex symbolic culture. This wasn't just about survival. It was about meaning, identity, and artistic expression. At Border Cave a nearly complete infant skeleton was discovered, accompanied by perforated Canoes Berstowi shells, dating to around 33,570 years ago. These shells, likely from the eastern Cape Coast, speak of long-distance trade or travel. The infant burial itself, adorned with these shells, may represent one of the earliest southern African examples of burial ornamentation. This suggests complex belief systems, rituals, and a profound respect for the deceased, even in such ancient times. The story continues to unfold, showing not only ingenuity but also remarkable resilience and adaptation. Around 19,000 years ago, Africans bearing haplogroup E1b1AV38 likely traversed across the Sahara, from east to west, demonstrating the vast movements and connections across the continent.
While the specifics are still debated, there's evidence suggesting a movement of Niger-Congo speakers, perhaps accompanied by undomesticated helmeted guinea fowls from West Africa, who then domesticated these birds by 3000 BCE, and subsequently, through the massive Bantu expansion spread across sub-Saharan Africa. Even the ancient history of diseases provides a narrative of human movement. According to Steverding 2020, schistosomes, the parasites causing schistosomiasis, evolved near the African Great Lakes and expanded along the Nile. From Egypt, they may have spread into Western Africa via migratory Yoruba people, and then further into the rest of sub-Saharan Africa, including southern and central Africa, via the migrating Bantu-speaking peoples. This grim tracing of disease paths inadvertently paints a vivid picture of ancient human migration patterns and interconnectedness. Genetic studies, using ancient DNA from places like Hora 1 rock shelter in Malawi, are now filling in the gaps with incredible detail. Individuals from between 16,897 and 15,827 years ago carried specific haplogroups, B2b and L5b. Later individuals from the same site, dating between 16,424 and 14,029 years ago, carried B2b1A2 tilde and L0D3/L0D3b. These are not just scientific markers. They are echoes of individual lives, of family lineages, offering a glimpse into the tapestry of human genetic diversity in this ancient land. Even later, between 10,000 and 5,000 years ago, an individual from Hora carried haplogroups BT and L0K2, and then around 8,173 to 7,957 years ago, L0A2. These data points collectively weave a deeply intricate genetic narrative of continuous human presence and diversification. And what about art? The walls of **Wonderwork Cave ** don't just hold evidence of fire. They hold parietal paintings, likely less than 1,000 years old, and small engraved stones from the later Stone Age, dating back some 500 years. These are not just decorations. They are expressions, stories, perhaps spiritual insights etched into the very fabric of the earth, providing a direct visual link to the inner lives of these ancient people. During the early Holocene around 9,000 years ago, we see evidence of further human interaction and admixture. Khoisan-related peoples admixed with the ancestors of the Igbo people, possibly in the Western Sahara, showing the fluidity and interconnectedness of ancient populations across vast distances. As humans continue to adapt, their bodies also evolved. The genomes of Africans reveal common adaptations in regulatory DNA, often related to diet, physiology, and the relentless evolutionary pressures from pathogens. Across sub-Saharan Africa, genetic adaptations to malaria, such as the RS334 mutation, the Duffy blood group, increased rates of G6PD deficiency, and sickle cell disease, have been found. These adaptations may have initially developed around 7,300 years ago. More than 90% of sub-Saharan Africans have the Duffy null genotype, offering a degree of protection against certain malarial parasites. In the challenging environment of the Kalahari Desert,
The letter 1 Situkhamani people show various possible genetic adaptations related to adipunctin, body mass index, and metabolism, all aiding in their survival. Even in more recent times in South Africa, genetic adaptations and strong susceptibility to tuberculosis have been found among coloreds, highlighting the ongoing dance between human biology and environmental pressures. Fast forward again to the Bantu migration a transformative event that reshaped the demographic and cultural landscape of sub-Saharan Africa. Bantu-speaking peoples, carrying their distinctive ceramics, began to migrate from West Africa into other areas of the continent. Specific ceramic types, like the Kalandu, spread into southeastern Africa, while the Eastern African Euro ceramic type of Lake Victoria branched out, becoming the quail type along the Indian Ocean shores, and the Nkope type spreading through Zimbabwe, Zambia, and Malawi. This wasn't just a movement of people. It was a movement of culture, technology, and language. Genetic analysis confirms this vast sweep of migration. From Kenya and Tanzania down to South Africa, Eastern Bantu-speaking Africans exhibit a clear north-to-south genetic cline. This, along with evidence of genetic homogeneity, points to a serial founder effect and significant admixture events occurring between Bantu-speaking Africans and existing African populations as the migration extended into South Africa. And this epic movement left its mark on art as well. Earlier red finger-painted rock art likely created between 6,000 and 1,800 years ago by Khoisan hunter-gatherer herders to the south of the Kei and Orange rivers, and by the considerably dark-skinned, occasionally bearded, bow and arrow-wielding Akafula hunter-gatherers in Malawi and Zambia, as well as by the Vihangona people in Transvaal, stands in stark contrast to later artistic expressions. The later white finger-painted rock art was created by Bantu-speaking farmers, or their Proto-Bantu progenitors, in parts of Tanzania, Malawi, Angola, Zambia, Zimbabwe, and the northern regions of Mozambique, Botswana, and Transvaal. In the Transvaal, this art was specifically created by Sotho speakers and Venda people. This later art tradition featured concentric circles, stylized humans, stylized animals, ox wagons, saurian figures, and notably depictions of crocodiles and snakes. These creatures were deeply associated with rainmaking, and crocodiles in particular with fertility. The white finger-painted rock art likely served purposes related to initiation rites and puberty rituals, signifying important life transitions and spiritual beliefs. Depictions from this art tradition have even been found on divination-related items like drums, initiation figurines, and masks. Fertility terracotta masks from Transvaal, dating to the 1st millennium CE, further underscore the depth and longevity of these symbolic practices. Alongside Iron Age archaeological sites from the 1st millennium CE, this suggests that the white finger-painted rock art tradition spanned from the early Iron Age to the later Iron Age, showcasing a continuity of cultural and spiritual expression. Even older themes, like down-headed animals, which appear in both South African rock art and round-head rock art, portray shamanic animal sacrifice as a rainfall ritual, connecting ancient spiritual practices across different artistic traditions. As we approach more recent millennia,
The genetic tapestry continues to reveal its intricate patterns. At Chinchera, Malawi, individuals from between 5,400 and 4,800 years ago carried haplogroup L0K2, and then between 5,293 and 4,979 years ago, L0K1. These individual genetic snapshots, though seemingly just letters and numbers, are powerful echoes of the diversity and movement of people across this remarkable continent. The pastoral Neolithic marks another pivotal shift. 3 later Stone Age hunter-gatherers were found to carry ancient DNA similar to Khoisan-speaking hunter-gatherers, reinforcing their enduring presence. But before the Bantu migration fully transformed the region, ancient DNA from Botswana reveals that East African herders migrated into southern Africa, bringing new ways of life, new technologies, and undoubtedly, new cultural influences. Then came the impact of the Iron Age Bantu agriculturalists of West African origin. Genetic evidence from 4 early agriculturalists shows that 2 earlier individuals carried ancient DNA similar to the Tsonga and Venda peoples, while 2 later agriculturalists carried DNA similar to the Nguni people. This indicates that the Bantu migration was not a single, monolithic wave, but rather a series of movements, each contributing to increased interaction and admixing between Bantu-speaking peoples and the indigenous Khoisan-speaking populations. The archaeological sites of Zaro, Taukom, and Nkoma in Botswana, yielding genetic information from early Iron Age individuals, further illuminate these complex movements and genetic blending. At Fingira, Malawi, an individual from between 2,676 and 2,330 years ago carried haplogroup L0F, adding another thread to this rich genetic tapestry. Around 2,300 years ago, as pastoralists and Bantu-speaking agro-pastoralists began arriving in southern Africa, a profound cultural and genetic mingling occurred. Bantu-speaking agro-pastoralists and Khoisan hunter-gatherers admixed, leading to the development of blended communities. These new societies incorporated both agro-pastoralist and hunter-gatherer ways of life, and their languages often developed with click consonants and Khoisan loan words. These amalgamated communities, my friends, are the very ancestors of the modern indigenous communities of South Africa, Botswana, and Namibia. The Xhosa, Sotho, Tswana, and Zulu peoples, among many others. This is where the ancient past truly meets the vibrant present, a powerful testament to interaction, adaptation, and the beautiful complexity of human history. The genetic markers continue to tell their story into more recent centuries. At Doonside, South Africa, an individual from between 2,296 and 1,910 years ago carried haplogroup L0D2. At St. Helena, between 2,241 and 1,965 years ago, A1B1B2A and L0D2C1. At Balato Bay, between 2,149 and 1,932 years ago, A1B1B2 and L0D2A1. Another individual from Balato Bay, 1986 to 1,831 years ago, carried A1B1B2 and L0D2C1. The Balato boy, found at the same location and dated to 1. 980 years ago, even showed evidence of Rickettsia felis, giving us a rare glimpse into the health and disease landscape of these ancient individuals. Further south, at Fareoscope Rock Shelter, an individual from between 2017 and 1748 years ago carried A1B1B2A and L0D1B2B1B. At Castilberg, between 1282 and 1069 years ago, L0D1A1A. At a land cave, between 533 and 453 years ago, L3E3B1. And at Newcastle, between 508 and 327 years ago, L3E2B1A2. At Mfungosi, between 448 and 308 years ago, L3E1B2. At Champagne Castle, between 448 and 282 years ago, L0D2A1A. Finally, at Valkren's Shelter, an individual dated to a mere 200 years ago, predominantly related to Khoisan speakers, but with a significant 15% to 32% relatedness to East Africans, carried haplogroups L0D3B1. This very recent snapshot encapsulates the millennia of intermingling, migration, and adaptation that forged the unique and deeply rooted heritage of Southern Africa, from the control of fire a million years ago to the complex tapestry of genetic and cultural exchange that shaped modern indigenous communities. Southern Africa stands as a testament to the enduring ingenuity, resilience, and adaptability of early humans. It's a place where the deep past isn't just a dusty archive, but a living, breathing narrative that continues to inform our understanding of who we are and where we truly come from. In our next segment, we'll continue this incredible journey, moving from the practical innovations of survival to the very dawn of abstract thought, exploring how art, advanced tools, and symbolic worlds truly began to define us as Homo sapiens *. Prepare for a deeper dive into the magnificent mind of our ancestors. Until then, keep vibing with history. Welcome back, history lovers, to another deep dive into the swirling currents of our collective past. Tonight, we're peeling back the layers of time to uncover the incredible journey of human ingenuity and the very dawn of abstract thought in prehistoric Southern Africa. So, dim the lights, perhaps grab a warm drink, and let the whispers of ancient winds carry you to a time when our ancestors began to shape not just tools, but entire worlds of meaning. Last time, we explored the rugged landscapes and the earliest stirrings of human life in this remarkable cradle of humanity. We traced the footsteps of our distant relatives, marveling at their sheer resilience and the fundamental adaptations that allowed them to survive and thrive. Now, we move beyond mere survival into a realm where the practical gives way to the profound, where sparks of innovation ignite into the flames of symbolic expression. This isn't just a story of stones and bones. It's a narrative of the human spirit unfurling its wings. Our journey begins, or perhaps continues, around 1 million years before the present, at a place called Wonderwork Cave in South Africa. Imagine, if you will, the flickering glow against the cavern walls, the crackling sound of wood, the warmth radiating outwards. This wasn't just a convenient accident. Here, hominins, our direct ancestors, were actively controlling fire. Think about the implications of that. not just utilizing a wildfire, but understanding how to tend it, to create it, to harness its power. Fire meant warmth against the biting cold of ancient nights. It meant light, pushing back the encroaching darkness and the unseen dangers within. It meant cooking, transforming raw, tough foods into something more digestible, unlocking nutrients, and quite possibly shaping the very evolution of our brains. This wasn't just a practical skill. It was a profound leap, a manipulation of the natural world that set our ancestors apart. It offered protection, a communal gathering point, and perhaps the very first stage for storytelling under a canopy of stars. Now, let's fast forward a bit to a period we call the Middle Stone Age, roughly between 260, 000 and 150, 000 years before today. This is where the story of the Khoisan, those remarkable people whose ancestral lineage stretches back further than almost any other modern human group, truly begins to unfold in southern Africa. Imagine them, expanding from East or Central Africa, charting a course across vast, untamed landscapes. Their early expansion and unique separation meant that for a significant stretch of time, before the great out-of-Africa migrations around 70,000 years ago, the ancestors of the Khoisan may have been the largest population among anatomically modern humans on the planet. Think of the sheer numbers, the vibrant communities, the wealth of knowledge and culture that must have flourished in this isolated cradle. Around 200,000 years ago, we see a crucial genetic divergence. Africans bearing haplogroup L0, predominantly found among the Khoisan of southern Africa, branched off from other African groups carrying haplogroup L16, who tended to reside further north. This genetic marker is a powerful echo from the deep past, a testament to the distinct lineage and ancient roots of these southern African populations. But it's between 130,000 and 75,000 years ago that something truly extraordinary begins to blossom. This is when we see the undeniable emergence of what we call behavioral modernity among southern Africans. What does that mean exactly? It means we start to see evidence of complex thought, symbolic expression, and social structures that go beyond mere practical survival. It's the time when long-term interactions between the regions of southern Africa and eastern Africa were firmly established, suggesting networks of communication, trade, and cultural exchange stretching across vast distances. Consider Border Cave, South Africa, a site that paints a vivid picture of this era. By at least 170,000 years ago, amid the Middle Stone Age, our southern African ancestors were cooking and eating Hypoxis angustifolia rhizomes. These aren't just any roots. They are rich in carbohydrates, providing essential energy for their demanding, migratory lives. This isn't just foraging. It's a deliberate choice, a knowledge of plant properties, and a testament to their sophisticated understanding of their environment. At Clay's River Caves, another fascinating detail emerges. Finger bones, manual distal phalanges, dated between 100,000 and 90,000 years ago, were recovered. These bones from an adult appear smaller than those of modern human populations and distinctly different from Neanderthal phalanges. Intriguingly, they bear a striking resemblance to phalanges found in the Die Kelder's cave, which authors suggest are more comparable to Holocene Khoisan populations. This subtle detail offers another thread connecting these ancient inhabitants to the living legacies of southern Africa's indigenous peoples. And then, in 92,000 BP, in what is now Malawi, we find evidence that foragers were not just living in their environment but actively shaping it. They utilized fire, not just for warmth or cooking, but to influence and alter their surrounding landscape. This speaks to a deeper understanding of ecology, perhaps for hunting, for encouraging certain plant growth, or for creating more habitable spaces. It's an early form of environmental engineering, a testament to their foresight and adaptability. But it's at Blombo's cave where the true revolution in abstract thought comes into sharp focus. Imagine small rock fragments, etched with drawn abstractions by Southern Africans, dated to an astonishing 73,000 years ago. These aren't crude scratches. They are deliberate patterns, symbols that a prime indicator of modern cognition. At a site called PP13B, we find further evidence of symbolic behavior in the form of scraped and ground ochre, likely used as pigments for body painting. This is similar to even more complex ochre utilization at Blombo's cave, slightly further west, around 70,000 years ago. These discoveries are nothing short of revolutionary. They directly contradict the long-held classical hypothesis that modern behavior, with its rich tapestry of symbolism and art, only emerged around 40,000 years ago, following a large cultural leap. No, the evidence from southern Africa tells a different story. It reveals that the seeds of abstract thought, of symbolic meaning-making, were sown far earlier, taking root and flourishing in this region long before our ancestors journeyed out of Africa to colonize the rest of the world. Perhaps the harsh climate and reduced food resources of the time played a role. It's theorized that these pressures may have driven people to the shores of Pinnacle Point, where they could exploit the abundant marine resources shellfish, whale, and seal. This dietary adaptation, requiring ingenuity and a deep understanding of coastal ecosystems, may have further fueled cognitive development. And the innovations didn't stop there. Between 65,000 and 37,000 years ago, bridging the Middle to Late Stone Age, Southern Africans developed the bow and arrow. Think about the complexity of this technology, the understanding of tension, aerodynamics, fletching, and projectile force. This wasn't just a better spear. It was a sophisticated hunting system, dramatically increasing their hunting range and efficiency, and fundamentally changing their relationship with their prey. Then we have the Lebombo bone, discovered in the mountainous region between Swaziland and South Africa. This baboon fibula, dated to an astounding 35,000 BCE, is quite possibly the oldest known mathematical artifact in the world. It bears 29 distinct notches, deliberately cut into its surface. What were these notches for? A lunar calendar, a tally of something significant. We may never know for certain, but its very existence speaks volumes about the early human capacity for abstraction, for tracking, for recording, for moving beyond the immediate present into the realm of organized thought. As we transition into the later Stone Age, around 75,000 years ago, the sand populations, direct ancestors of the Khoisan, were spread widely across much of southern and eastern Africa. Imagine these resilient people, carrying their distinct culture, their intimate knowledge of the land, across vast territories. By 20,000 years ago, these populations, carrying haplogroup L0D, may have further expanded, a movement potentially linked to the fascinating spread of click consonants into East African languages like Hadza. Language, that most complex of human inventions, carries echoes of these ancient migrations and cultural exchanges. The later Stone Age also saw the Sangoan industry flourish in southern Africa, particularly in areas receiving less than a meter of annual rainfall. This adaptation to drier environments further showcases their resourcefulness and ability to tailor their technology to specific ecological niches. Sibudu Cave is another treasure trove of early human technology. Here, archaeologists have unearthed a staggering array of innovations. A bone point, a possible arrowhead, pushing back the origin of bow and bone arrow technology to 61,000 BP, a full 20,000 years earlier than previously thought. The earliest known bone needle, also from 61,000 BP, shows wear patterns identical to those used for puncturing animal hides, suggesting sophisticated clothing or shelter construction. Then there's the earliest example of a compound glue, a mixture of plant gum and red ochre, used for hafting stone points into wooden handles to create spears, dated no later than 71,000 BP. This isn't just sticking two things together, it's chemistry, an understanding of material properties, and a testament to complex tool making. We also find shell beads, a clear sign of personal adornment and symbolic expression, and the earliest use of bedding, dating back to approximately 77,000 BP, with Cape laurel likely used for its insecticidal properties. And in a remarkable discovery, the earliest use of milk, specifically casein, as a paint binder in a milk ochre mixture, from 49,000 BP. This is art, chemistry, and resourcefulness all rolled into one. The cave also yielded carbonized and uncarbonized seeds and nuts, showing a diverse diet and sophisticated foraging strategies. Like the earlier Still Bay industry, the creators of Khoisan's port artifacts, dating back to at least 50,000 BP, engaged in rich symbolic behavior. They left behind engraved ochre, meticulously etched ostrich eggshells, and carefully crafted shell beads. The sheer abundance and diversity of ochre use as a pigment, whether for objects or body painting, has been interpreted as reflecting an increasingly complex symbolic culture, where meaning and identity were deeply interwoven with visual expression. At Border Cave, another poignant discovery, a nearly complete infant skeleton, accompanied by perforated Canyu's Berstowi shells. These shells, dated to around 570 years ago, likely came from the distant eastern Cape Coast, suggesting exchange networks or significant travel. This infant burial, with its adornments, stands as one of the earliest southern African examples of burial ornamentation, speaking to deep emotional bonds, ritual practices, and perhaps beliefs about the afterlife. Around 19,000 BP, we see another significant migration pattern as Africans bearing haplogroup E1b1AV38 likely traversed across the Sahara, from east to west. This vast movement highlights the incredible distances covered by early human populations, adapting to new environments and spreading their genetic heritage across the continent. The narrative also touches upon later migrations and genetic interactions. The Niger-Congo migration, potentially originating in West Africa or Kordofan, Sudan, saw groups like the Mand, accompanied by undomesticated helmeted guinea fowls, traversing into West Africa. By 3000 BCE, these guinea fowls were domesticated, and through the Great Bantu expansion, these people and their innovations spread across sub-Saharan Africa, reaching Central, East, and Southern Africa. And in a fascinating, albeit non-definitive theory, Steverting, 2020, suggests a possible link between the evolution of schistosomes near the African Great Lakes, their expansion along the Nile, and their spread into West Africa via migratory Yoruba people, and subsequently into the rest of sub-Saharan Africa, including Southern Africa, carried by the migratory Bantu-speaking peoples. These subtle, often unseen, movements of pathogens are a powerful reminder of the intricate connections between human migration, environment, and health. From Hora 1 rock shelter in Malawi, we have fascinating glimpses into individual genetic histories, with individuals dated between 16,897 and 14,029 BP carrying various haplogroups, painting a detailed picture of ancient lineages. Later, at Hora, an individual estimated between 10,000 and 5,000 BP carried different markers, showing the evolving genetic landscape. The enduring power of symbolic expression is also evident in the rock art of Wonderwork Cave. Within the first 40 meters of the entrance, parietal paintings, though possibly less than 1,000 years old, speak to a long tradition. More ancient, however, are the small engraved stones found within the deposits, primarily from the later Stone Age sequence, dating back some 500 years. These tangible links to ancient artistic expression remind us of the persistent human need to leave a mark, to tell a story, to connect across generations through images. During the early Holocene, around 9000 BP, we find evidence of Khoisan-related peoples admixing with the ancestors of the Igbo people, possibly in the Western Sahara. These genetic intersections are powerful reminders that human history is not a series of isolated narratives, but a rich tapestry of interwoven stories, migrations, and shared heritages. The human genome itself tells a story of adaptation. In Africa, we find numerous cases of adaptation related to diet, physiology, and evolutionary pressures from pathogens. The widespread genetic adaptation to malaria, for instance, including the RS334 mutation, the Duffy blood group, and increased rates of G6PD deficiency and sickle cell disease, likely developed around 7,300 BP. More than 90% of sub-Saharan Africans carry the Duffy null genotype, a strong protective adaptation. In the Kalahari Desert, the letter 1 C2 people show possible genetic adaptations related to adiponectin, body mass index, and metabolism. In South Africa, the colored population shows a genetic adaptation, RS 28,647,531, on chromosome 4q22, alongside a strong susceptibility to tuberculosis, illustrating the complex interplay of genetic inheritance and environmental factors. Further genetic insights come from Fingira rock shelter in Malawi, with individuals dated between 6,179 and 2,341 BP, carrying various haplogroups, adding more detail to the genetic map of ancient southern Africa. Then, we encounter the Great Bantu expansion. Bantu-speaking peoples, carrying their distinctive ceramics, migrated from West Africa into other areas of sub-Saharan Africa. The Kalindu ceramic type spread into southeastern Africa, while the Eastern African Euro ceramic type from Lake Victoria made its way along the Indian Ocean shores as the Quail ceramic type, and further into Zimbabwe, Zambia, and Malawi as the Nkope ceramic type. This isn't just a movement of people, it's a spread of culture, technology, and language. From Kenya and Tanzania down to South Africa, Eastern Bantu-speaking Africans show a clear north-to-south genetic climb, with evidence of genetic homogeneity suggesting a serial founder effect and significant admixture with other African populations as the Bantu migration spanned into South Africa. This dynamic interaction between migrating Bantu groups and existing Khoisan populations is a crucial part of the story. Rock art, in its various forms, provides another rich source of cultural insight. The earlier red finger-painted rock art, some of it dating back between 6,000 and 1,800 BP, was created south of the K River and Orange River by Khoisan hunter-gatherer-herders. In Malawi and Zambia, the considerably dark-skinned, occasionally bearded bow and arrow-wielding Acapula hunter-gatherers, who resided there until the 19th century CE, also created this art. In Transvaal, the Vihangona people contributed to this tradition. Later, a distinct white finger-painted rock art emerged, created by Bantu-speaking farmers or their Proto-Bantu progenitors. In areas of Tanzania, Malawi, Angola, Zambia, and Zimbabwe, as well as northern regions of Mozambique, Botswana, and Transvaal. The Transvaal rock art, specifically in areas like Soutpansberg and Waterberg, was created by Sotho speakers, Burwa, Koni, Tilakwa, and Venda people. This art often included concentric circles, stylized humans and animals, ox wagons, saurian figures, and powerful depictions of crocodiles and snakes, both intimately associated with rainmaking, with crocodiles also symbolizing fertility. This white finger-painted rock art may have been intricately linked to initiation rites and puberty rituals, serving as a powerful visual language for social transitions. Depictions from this tradition have even been found on divination-related items like drums, initiation figurines, and masks. Fertility terracotta masks from Transvaal, dated to the 1st millennium CE, along with Iron Age archaeological sites, suggest this vibrant artistic tradition spanned from the early to the later Iron Age. Even the down-headed animals seen in South African rock art, portraying shamanic animal sacrifice as a rainfall ritual, echo similar themes found in round-head rock art, highlighting potential widespread symbolic practices. Further genetic data from Chenchura, Malawi, with individuals estimated between 5,400 and 4,800 BP, and again between 5,293 and 4,979 BP, carrying specific haplogroups, continues to fill in the genetic jigsaw puzzle of ancient southern Africa. Moving into the pastoral Neolithic, we find a complex interplay of populations. Ancient DNA from Botswana reveals that 3 later Stone Age hunter-gatherers carried genetic markers similar to Khoisan-speaking hunter-gatherers. But significantly, prior to the Bantu migration, East African herders also migrated into southern Africa. This is a crucial detail. The region wasn't simply settled by one group, but by waves of migration and interaction. Of 4 Iron Age Bantu agriculturalists of West African origin, 2 earlier individuals carried ancient DNA similar to Tsonga and Venda peoples, while 2 later agriculturalists showed genetic similarities to Nguni people. This indicates a multifaceted Bantu migration, with different movements of people, leading to increased interaction and admixture between Bantu-speaking and Khoisan-speaking populations. Genetic findings from Zaro, Taukom, and Nkoma in Botswana, dating to the early Iron Age, between 1400 and 900 BP, further detail the specific haplogroups carried by these ancient individuals, revealing the genetic melting pot that was forming. At Fingira, Malawi, an individual estimated between 2676 and 2330 BP carried haplogroup L0F, adding to the intricate genetic map. Around 2300 BP, as pastoralists and Bantu-speaking agro-pastoralists began to arrive in southern Africa, a profound cultural and genetic fusion began. These Bantu-speaking agro-pastoralists and Khoisan hunter-gatherers admixed, resulting in the development of blended communities. These communities adopted languages with click consonants and Khoisan loan words, a clear testament to this cultural exchange. These amalgamated societies would, over time, develop into the modern indigenous communities of South Africa, Botswana, and Namibia, including the Xhosa, Sotho, Tswana, and Zulu people. This is the birth of the vibrant, diverse cultural landscape we recognize today, born from millennia of migration, interaction, and the incredible human capacity for adaptation and cultural synthesis. Finally, a series of individuals from various sites across South Africa, including Doonside, St. Helena, Ballito Bay, Fareyoskup Rock Shelter, Casteelberg, a land cave, Newcastle, Mfungosi, Champagne Castle, and Valkrans Shelter, provide further genetic snapshots from the last 2 millennia. From individuals estimated between 2296 BP and 1910 BP, carrying haplogroup L0D2, to Ballito Boy, estimated at 980 years ago, found to have Rickettsia felis. These ancient remains continue to illuminate the health, migrations, and genetic makeup of our ancestors. The individual from Valkrans Shelter, dated to 200 BP, predominantly related to Khoisan speakers, but with 15% to 32% East African ancestry, perfectly encapsulates the complex and beautiful genetic mosaic that is Southern Africa's legacy. So, as we conclude this segment, remember that the story of Southern Africa is not merely one of survival, but of innovation, of symbolic expression, of profound cultural exchange. From the control of fire to the creation of the oldest mathematical artifact, from the earliest art to the complex weaving of diverse genetic lineages, our ancestors in this remarkable region laid the foundation for not just modern humanity, but for the rich tapestry of cultures that continues to thrive there today. Next, we will journey further into the intricate web of migrations, admixture, and the birth of new societies across the continents, as humanity's story continues to unfold. Until then, keep those historical curiosities burning. Welcome back, everyone, to Vibing History. Settle in, find your comfortable spot, and let the echoes of the ancient world wash over you. In our last segment, we delved into the earliest sparks of human ingenuity, exploring the astonishing cognitive leaps that define the Middle Stone Age in southern Africa, the birth of abstract thought, the profound symbolism etched into ochre, and the sophisticated tools that shaped early human existence. Today, we journey deeper, tracing the intricate dance of human movement across this vast and ancient land. We're going to explore the crossroads of continents, the profound shifts brought about by migrations, and the beautiful, complex tapestry woven from the admixture of different peoples. Prepare to witness the birth of new societies, shaped by environmental pressures, innovative technologies, and the enduring human spirit of exploration. Imagine, if you will, the sheer scale of time we're discussing. 1 million years ago, a monumental shift occurred in a place called Wonderwork Cave in what is now South Africa. A breakthrough so fundamental that it would forever alter the course of human development, the controlled use of fire. Picture the flickering flames, casting long shadows against ancient cave walls, offering warmth against the chill, protection against predators, and a revolutionary way to process food. This wasn't just a discovery. It was a cornerstone of civilization, marking the very beginning of the early Stone Age in this remarkable region. Now, fast forward a considerable chunk of time to an era that truly begins to sculpt the human landscape of southern Africa. Before 150,000 years ago, and possibly even as far back as 260,000 years ago, the ancestors of the Khoisan people embarked on a significant expansion. They moved, perhaps from East Africa or even Central Africa, into the fertile and diverse lands of Southern Africa. This early and profound separation, this remarkable journey, suggests that these ancestors of the Khoisan may have constituted the largest human population among anatomically modern humans for a very long stretch of time, from their initial divergence until the momentous out-of-Africa migration, roughly 70,000 years ago, when our ancestors began their epic journey across the globe. Think about that for a moment. A significant portion of the early human story played out in southern Africa, with these pioneering groups laying down deep roots. Around 200,000 years ago, we see another fascinating divergence. African populations carrying a specific genetic marker, haplogroup L0, which includes many Khoisan people, separated from other African groups bearing haplogroup L16, who tended to reside further north. This genetic evidence paints a picture of distinct ancestral lineages forming and evolving, each adapting to their unique environments. Between 130,000 and 75,000 years ago, the region witnessed an explosion of what we call behavioral modernity among Southern Africans. This wasn't just about survival. It was about expression, symbolism, and increasingly complex social structures. During this period, long-term interactions began to solidify between the communities of Southern Africa and Eastern Africa, indicating a growing web of connections and exchanges across vast distances. Imagine the stories shared, the knowledge passed down, and perhaps even the occasional trade of tools or resources, all bridging these immense geographical gaps. And what fueled these movements? What sustained these early explorers? By at least 170,000 years ago, deep in the Middle Stone Age, the inhabitants of Border Cave in South Africa were cooking and consuming *Hypoxis angustifolia rhizomes. These plant roots, rich in carbohydrates, would have provided crucial energy for their migratory activities, for their hunting, and for their daily lives. It's a testament to their deep understanding of their environment and their ingenuity in extracting sustenance from the land. The Khoisan River caves, another incredible window into this period, have yielded finger bones dating back between 100,000 and 90,000 years ago. These tiny fragments of an adult individual tell a silent story. They are smaller than those of modern humans, yet distinct from Neanderthal phalanges, and remarkably similar to the bones of later Holocene Khoisan populations. It's a tantalizing glimpse into the physical characteristics of these ancient people, hinting at continuity and adaptation over millennia. Further north, in what is now Malawi, around 92,000 years ago, we find evidence of Malawian foragers actively using fire to shape and influence their environment. This wasn't just for warmth or cooking anymore. It was about landscape management, perhaps clearing brush to encourage new growth, or driving game. It speaks to a growing mastery over their surroundings, a deliberate manipulation of nature to their advantage. Now let's talk about the mind. At Blombo's cave, a site that truly redefined our understanding of early human cognition, small rock fragments inscribed with abstract designs, dating back 73,000 years ago, stand as a prime indicator of modern cognition. These weren't random scratches. They were deliberate, symbolic expressions, proving that our ancestors in Southern Africa were thinking in complex, abstract ways far earlier than previously imagined. And at another site, PP13b, we find evidence of scraped and ground ochre, used perhaps as pigment for body painting. This sophisticated use of ochre, similar to the discoveries at Blombo's cave around 70,000 years ago, directly contradicts the older hypothesis that modern behavior emerged in a sudden cultural leap, only 40,000 years ago. Instead, we see a gradual, intricate unfolding of cognitive complexity. It's believed that harsh climates and diminishing food resources might have driven people to coastal areas like Pinnacle Point, where they discovered a new, reliable food source. Marine creatures, shellfish, whale, and seal would have provided a rich bounty, further diversifying their diet and enabling their continued survival and expansion. And then, a truly groundbreaking invention, the bow and arrow. Between 65,000 and 37,000 years ago, Southern Africans developed this revolutionary hunting technology. Imagine the impact. The ability to hunt from a distance with greater accuracy and less risk would have transformed their hunting strategies and their ability to procure food. And for those who appreciate the origins of mathematics, consider the Lebombo bone.
Found in the mountainous regions of Swaziland and South Africa, this baboon fibula, dated to 35,000 BCE, bears 29 distinct, deliberately cut notches. It's considered by many to be the oldest known mathematical artifact, a silent testament to early human counting and record keeping. As we transition into the later Stone Age, around 75,000 years ago, the San populations, direct ancestors of the Khoisan, had spread throughout much of southern and eastern Africa. Their resilience and adaptability allowed them to thrive across diverse landscapes. And then, around 20,000 years ago, these populations, carrying a specific genetic marker, haplogroup L0D, underwent further expansion. This movement is even linked to the spread of click consonants, those unique linguistic sounds, into East African languages like Hadza. It's a powerful reminder of how language and genes can tell interconnected stories of human migration and interaction. The Sangoan industry, a distinct cultural phase of the later Stone Age, flourished in southern Africa in areas with less than a meter of annual rainfall. This indicates a sophisticated adaptation to drier environments, showcasing their ability to thrive where resources might have been scarcer. Sibudu Cave, another incredible archaeological treasure trove, offers a plethora of insights into early human technology during this period. Here, we've found a bone point, quite possibly an arrowhead, pushing back the origin of bow and bone arrow technology to an astonishing 61,000 years ago, a full 20,000 years earlier than previous estimates. Imagine the sheer ingenuity. And the earliest known bone needle, also from Sibudu, dating to 61,000 years ago, with wear patterns identical to needles used for puncturing animal hides. This points to sophisticated clothing, perhaps sewn to protect against the elements. But it gets even more fascinating. Sibudu also yielded the earliest example of a compound glue, a mixture of plant gum and red ochre, used for hafting stone points into wood handles to create spears, no later than 71,000 years ago. This wasn't just a simple adhesive. It was a carefully formulated blend, demonstrating an advanced understanding of materials science. And shell beads, though slightly more recent than those at Blombo's cave, reinforce the idea of symbolic expression and personal adornment. Perhaps most remarkably, Sibudu provided evidence of the earliest use of bedding, around 77,000 years ago, with Cape laurel leaves deliberately placed on top, likely for their insecticidal properties. This wasn't just about comfort. It was about hygiene and preventing infestations, showcasing a remarkable understanding of natural remedies. And in a testament to their artistic and practical skills, the earliest use of milk casein as a paint binder in a milk-ochre mixture, dating to 49,000 years ago, has also been found. Beyond tools and art, Sibudu Cave also reveals details about their diet. Dried fruits, carbonized and uncarbonized seeds and nuts, all from the Middle Stone Age from before 60,000 years ago to approximately 37,000 years ago. This demonstrates a diverse and well-understood foraging strategy. Just like the earlier Stilbé industry, the creators of the Khoisans port artifacts dating back at least 50,000 000 years ago, engaged in rich symbolic behavior. They left behind engraved ochre, ostrich eggshells, and shell beads. The particularly abundant and diverse use of ochre as a pigment for objects or skin has been interpreted as a reflection of an increasingly complex symbolic culture, a society where meaning and representation played a profound role. At Border Cave, a nearly complete infant skeleton, accompanied by perforated *Canus Berstowi shells, dating to around 570 years ago, suggests a poignant and early example of burial ornamentation in southern Africa. These shells, likely from the eastern Cape Coast, speak to the emotional depth and perhaps spiritual beliefs of these ancient communities. Around 19,000 years ago, another significant migration occurred. Africans carrying haplogroup E1b1AV38 likely traversed the Sahara, moving from east to west. This highlights the fluidity of ancient populations and their remarkable ability to cross challenging landscapes. The narratives of migration become increasingly intricate. While the Niger-Congo migration may have originated in West Africa and moved towards Kordofan or vice versa, what is clearer is that Niger-Congo speakers, perhaps groups like the Mand, embarked on a journey that would eventually lead to the domestication of helmeted guinea fowls by 3000 BCE. From there, the monumental Bantu expansion began, spreading these communities, their languages, and their agricultural practices into Central Africa, East Africa, and eventually Southern Africa. Consider a less pleasant but equally significant aspect of ancient migration: disease. According to Steverding 2020, near the African Great Lakes, schistosomes, parasitic flatworms evolved. They then expanded along the Nile River. From Egypt, their presence likely spread, carried by migratory Yoruba people into Western Africa. And from there, these parasites would have continued their journey, carried by migrating Bantu-speaking peoples, into the rest of sub-Saharan Africa, including southern and central Africa. It's a stark reminder that migrations carried not only people and culture, but also the challenges of their environment. Genetic studies on individuals from Hora 1 rock shelter in Malawi reveal further layers of this ancient tapestry. An individual from between 16,897 and 15,827 years ago carried haplogroups B2b and L5b. Another, from between 16,424 and 14,029 years ago, carried B2b1A2 tilde and L0D3/L0D3b. And later, between 10,000 and 5,000 years ago, an individual from Hora carried BT and L0K2. These genetic markers are like footprints in time, tracing the movements and connections of diverse groups across the continent. Rock art also provides invaluable insights. Within the Wonderwork Cave, parietal paintings, possibly less than 1,000 years old, adorn the first 40 meters from the entrance, and small engraved stones, primarily from the later Stone Age sequence, date back some 500 years. These artistic expressions are a direct link to the minds and worlds of these ancient inhabitants. During the early Holocene around 9,000 years ago, a fascinating admixture event occurred. Khoisan-related peoples mingled with the ancestors of the Igbo people, possibly in the Western Sahara. This highlights the vast geographical extent of human interaction and the dynamic nature of ancient populations. Genetic adaptation is another crucial piece of the puzzle. The genomes of Africans frequently show adaptations in regulatory DNA, often related to diet, physiology, and the pressures of pathogens. Across sub-Saharan Africa, genetic adaptations to malaria, such as the RS334 mutation, the Duffy blood group, increased rates of G6PD deficiency, and sickle cell disease are widespread. These adaptations likely began around 300 years ago, reflecting a long evolutionary struggle against a persistent threat. Over 90% of sub-Saharan Africans possess the Duffy null genotype, a powerful defense against malaria. In the Kalahari Desert, the letter 1C2 Kamani people exhibit various possible genetic adaptations related to adiponectin, body mass index, and metabolism, showcasing unique responses to their challenging environment. In South Africa, genetic adaptations and a strong susceptibility to tuberculosis have been found among colored communities, demonstrating ongoing evolutionary processes. Back at Fingira Rock Shelter in Malawi, we see more genetic threads. An individual from between 179 and 341 years ago carried B2 and L0D1. Later, between 177 and 923 years ago, an individual carried BT and L0D1C. And between 175 and 913 years ago, another carried BT and L0D1B2B. These markers, again, provide specific details about the lineages that populated this region over millennia. The arrival of Bantu-speaking peoples, carrying their distinctive ceramics from West Africa into other parts of sub-Saharan Africa, was a transformative event. The Kalandu ceramic type, for example, spread into southeastern Africa. The Euro-ceramic type from Lake Victoria in eastern Africa then transformed into the quail type along the Indian Ocean coast, and further into the Nkope type in Zimbabwe, Zambia, and Malawi. This spread of pottery styles is a tangible indicator of their movements and the cultural exchanges that accompanied them. From Kenya and Tanzania down to South Africa, Eastern Bantu-speaking Africans exhibit a north-to-south genetic cline. This, combined with evidence of genetic homogeneity, strongly suggests a serial founder effect and significant admixture events between Bantu-speaking Africans and other African populations as the Bantu migration swept across the continent, reaching as far south as South Africa. And let's not forget the captivating language of rock art. The earlier red finger-painted art, likely created between 6,000 and 1,800 years ago, south of the K River and Orange River, was the work of Khoisan hunter-gatherer herders. In Malawi and Zambia, the considerably dark-skinned, sometimes bearded bow and arrow-wielding Acapula hunter-gatherers who lived there until the 19th century CE also left their mark. In Transvaal, it was the Vihangona people. Later, the white finger-painted rock art, created by Bantu-speaking farmers or their Proto-Bantu ancestors, appeared in areas of Tanzania, Malawi, Angola, Zambia, and Zimbabwe, as well as in the northern regions of Mozambique, Botswana, and Transvaal. Specifically, in Transvaal, this art was created by Sotho speakers and Venda people.
These artworks depicted concentric circles, stylized humans and animals, ox wagons, saurian figures, and powerful images of crocodiles and snakes, both deeply associated with rainmaking, and crocodiles in particular with fertility. This white finger-painted art likely served purposes related to initiation rites and puberty rituals, connecting art directly to spiritual and social practices. Depictions from this tradition have even been found on divination-related items like drums, initiation figurines, and masks. Fertility terracotta masks from Transvaal, dated to the 1st millennium CE, along with Iron Age archaeological sites from the same period, indicate that this white finger-painted rock art tradition spanned from the early Iron Age to the later Iron Age, a sustained and vibrant artistic expression. The down-headed animals appearing in South African rock art, which portray shamanic animal sacrifice as a rainfall ritual, also appear in round-head rock art, showing continuity of symbolic meaning. Further genetic insights from Chenchura in Malawi reveal individuals carrying haplogroup L0K2 between 400 and 800 years ago, and L0K1 between 293 and 979 years ago. Each of these genetic markers is a whisper from the past, detailing the intricate movements and relationships of these early inhabitants. Now, let us shift our focus to the pastoral Neolithic, a period where new ways of life emerged, shaped by the keeping of livestock. Ancient DNA from 3 later Stone Age hunter-gatherers shows striking similarities to modern Khoisan-speaking hunter-gatherers, reinforcing the deep ancestral connections. But a new wave was coming. Before the full Bantu migration, ancient DNA from Botswana reveals that East African herders made their way into southern Africa, bringing with them pastoralist traditions. The Iron Age brought a different kind of agriculturalist. Out of 4 Iron Age Bantu agriculturalists of West African origin, 2 earlier individuals carried ancient DNA similar to Tsonga and Venda peoples, while 2 later ones carried DNA similar to Nguni people. This is crucial. It indicates that the Bantu migration wasn't a single, monolithic wave, but rather multiple movements of peoples, each with their own genetic signatures, resulting in increased interaction and profound admixture between Bantu-speaking and Khoisan-speaking populations. At Zaro in Botswana, 2 individuals from the early Iron Age, around 400 years ago, carried fascinating haplogroups. One had E1B1A1A1C1A and L3E1A2, while the other carried E1B1B1B2B, EM293, ECTS 10880, and L0K1A2. At Taukom, another early Iron Age site from 100 years ago, an individual carried E1B1A1 EM2, EZ1123, and L0D3B1. And at Nkoma from 900 years ago, an individual carried haplogroup L2A1F. These genetic details are like fragments of an ancient family tree, connecting these individuals to the broader narrative of human movement and settlement. Back in Malawi, at Fingira, an individual from between 676 and 330 years ago carried haplogroup L0F, demonstrating continued genetic diversity in the region. As pastoralists and Bantu-speaking agro-pastoralists began arriving in southern Africa around 300 years ago, a pivotal process of admixture began. Bantu-speaking agro-pastoralists and Khoisan hunter-gatherers intermingled, leading to the development of blended communities. These new societies incorporated elements of both lifestyles, agro-pastoralism and hunter-gathering, and their languages often adopted click consonants and Khoisan loan words. These amalgamated communities, over time, would develop into the rich tapestry of modern indigenous communities we know today: the Xhosa, Sotho, Tswana and Zulu peoples of South Africa, Botswana and Namibia. This is where the deep roots of modern Southern African identity truly begin to intertwine. The genetic record from various sites in South Africa further illustrates this dynamic period. At Doonside, an individual from between 296 and 910 years ago carried haplogroup L0D2. At St. Helena, between 241 and 965 years ago, an individual carried A1B1B2A and L0D2C1. At Balato Bay, between 149 and 932 years ago, we find A1B1B2 and L0D2A1. Another individual from Balato Bay, from between 986 and 831 years ago, carried A1B1B2 and L0D2C1. And the famous Balato Boy, from around 980 years ago, was found to have Rickettsia felis *, offering a glimpse into ancient pathogens. At Pharaohscope Rock Shelter, an individual from between 2017 and 748 years ago carried A1B1B2A and L0D1B2B1B. Later, at Castelberg, between 282 and 1069 years ago, an individual carried L0D1A1A. At a land cave between 533 and 453 years ago, L3E3B1 was found. At Newcastle, between 508 and 327 years ago, L3E2B1A2. At Mfungosi, between 448 and 308 years ago, L3E1B2. At Champagne Castle, between 448 and 282 years ago, L0D2A1A. And finally, at Valkren's Shelter, an individual from around 200 years ago shows predominant relation to Khoisan speakers, but with a significant portion, 15% 32%, related to East Africans, carrying haplogroup L0D3B1. Each of these genetic markers, each of these archaeological finds, is a thread in the magnificent tapestry of Southern Africa's prehistory. They tell a story not of isolated groups, but of constant movement, interaction, adaptation, and the incredible resilience of the human spirit. From the earliest flicker of controlled fire to the complex, blended societies that emerged through migration and admixture, Southern Africa has always been a dynamic crossroads, a crucible of human experience. Thank you for joining me on this deep dive into the crossroads of continents. I hope you found this journey as captivating as I did. Join us next time on Vibing History, as we continue to uncover the rich and often surprising stories of our shared past. Until then, keep vibing with history. And so, our epic journey through the prehistoric heart of Southern Africa draws to a close. From the first controlled fires to the intricate tapestry of migrating peoples and emergent cultures, we've seen how resilience, Innovation and adaptation forged the very foundations of human society. It's a humbling thought, isn't it, to consider the echoes of these ancient lives still resonating within us today. I hope this deep dive has sparked your imagination and offered you a fresh perspective on the incredible odyssey of our ancestors. Don't forget to like, comment with your thoughts, and share this narrative with those who seek to understand the vastness of history. And of course, subscribe and follow for more journeys into the ancient world. What other untold stories are you eager to explore? Let me know in the comments below. Until next time, keep vibing with history.